Hello, guys. We back here for one more lesson. I hope you all well right now in Tekniikka. First of all, I ask you to share this video with your friends. Let me know in the comments if the audio is fine or not. I really appreciate your presence, guys. So today we're gonna talk about variable. This is our first lesson, our first C programming lesson. And we hope at the end of this course you'll be able to really be good C programmers, and the most important is thinking logically. So talking about variables, I really need to check whether my audio is fine or not, because sometimes it's fucked up, and I wouldn't like for you guys to hear me talking with very bad audio. That will be too bad for me. Yeah. So continuing, um, I'm talking about C programming language, but today we talking about this. We have two topics today: definition and variable scopes. So let's start talking about a variable, the concept of a variable. We have right now to present to you three different concepts, okay, or two. Let's consider two. One in mathematics and a different concept for programming. In math, a variable is a single which we use as a letter, okay, maybe a letter or a word, something like that. In math, it is mainly um, letters, and we use that letter to represent or to designate the elements of a data set. The data set, the elements in the data set, whether they are numbers or some non-numbers, some non-numerical values, they represent the variable domain. So there are two different uh, types of variables when we talk about there are two different types of variables when we talk about the nature of the values of that variables of the data set. They are quantitative variables and qualitative. The quantitative variables are always numbers. Sometimes the variable is discrete, and another time the variable is continuous. Okay, when we say a variable is discrete, we have only integer numbers, and when the variable is continuous, we can have numbers floating point with floating point numbers. And a qualitative variable is a variable which the values are not numerical. The values are really qualitative, like colors, name, gender, stuff like that, to specify um, a type of thing. Okay, the type. Let's go to programming. In programming, a variable is a symbol that may be a letter or or even a word, but there are some rules that I'm going to show in the next slide. And these symbols are used to represent a session. A session we have in the RAM memory, to store some value. So um, going a little bit further, we have we have now identifiers. The concept of an identifier, I really like that, because identifier are names that we use to to represent variables. We name the variables using identifiers. Maybe any normal variable or some object. So the name of an identifier must always start with a letter, not with a number or stuff like that, or symbols or different symbols. We can start with letters, or there is an exception that we can start a variable or an identifier by an underscore. And then you can use letters and underscore, okay? But you cannot use special characters and spaces. You cannot use that. There are some examples. For example, num is a valid variable, only letters. Value 3 is valid because we start with a letter and we have a number. That's allowed. Value x with an underscore in the between value and x, that's allowable. Okay, we have a variable separated by multiple underscores, that's fine. But in the invalid subset, we have 3, the number 3, then tigers. That's bad because we started a variable using a number. If the number 3 was at the end of the variable in the middle, that'll be fine. O is not good because we have a special char with the exclamation mark. We cannot use that. Okay, X value is not valid because the the hyphen is in the middle, or is in the middle of the variable. We cannot use hyphen because this is a special char, but we can use underscore. Okay, underscore is kind of the only special char that we can use inside an identifier. So let's continue. I don't want to transform this video in a blah 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 because I'm excited to go to the code. So global variables and local variables. A global variable is a variable that you define outside a block of a block of instructions. A block of instructions is characterized by curly braces. Everything which is inside curly braces, we consider that a block of instruction. And a global variable generally is outside a block. Any variable which is defined, declared and defined outside of the block, that variable is considered global to this block, and also the other blocks below. But a local variable is a variable which is defined within a block. If you define a variable within a block, that variable is only valid for that block, for that specific block. This is the definition of local. So this is the last slide before going to the code. Okay. In this last slide, we have a modifier and scope. The modifiers, I really like that because this is a little bit advanced. For now, you're gonna see that very easy. But in the future, when you really coding for real applications, you'll see the how important are these modifiers. So the first modifier I want to introduce is auto. Auto is a modifier that specifies that a variable is local. But if you don't specify auto before the variable name, then that will be automatically because this is the default variable, the default behavior. So const is a modifier that if you put before a variable, then that variable after you initialize the variable with some value, you will not be able to modify that value anymore. Static, a variable that you define as static, that value doesn't belong to a single scope. This is a little bit tricky, but I have to show this in practice because static variable that makes more sense when it is inside a function. Then afterwards, we're gonna talk about functions, and you will understand that if a variable is static, that variable doesn't belong to that scope. The variable belongs to the whole program. So the value of that variable is shared between all the scopes. Okay, shared by different scopes. Extern, when you extern, An external variable is a variable that is only declared in your scope. When you say extend to some variable, that variable is only being defined, is only being declared, but not defined. I'm going to show you the difference between declaring a variable and defining it. When you declare, the variable is not, you're not allocating the variable in the memory. But when you instantiate the variable, when you define, you are reserving a space in the memory. That's the difference. If a variable is defined inside a file with source code, with code, and you want to use in another code, you can say in the second code, in the second file, that that variable is external. So you are not going to reserve another space in the memory because you only declaring that that variable exists, and then you can use the space or the allocation of the variable which is defined in the other file. Okay, this is what means a variable to be external. So register, a register is a variable that you cannot have a global variable as register. A register must be local because its value you have to access as fast as possible. Okay, as faster as possible, because it's generally related to very important positions, important sectors in the hardware. Okay, volatile. A volatile is also used to manipulate spaces in the hardware. But the most important about relate to about volatile is that if you have uh, if you have um, some resource, some physical resource, some boards or some processor or some, let's say, some device that you need to manipulate, and you know that there are other processes in the same program that would also manipulate that section, that critical section, then you declare that as volatile. So in this case, the compiler, which is the environment which is running your code, will not will not optimize your code in its way. Sometimes the compiler optimizes the code for us, and when we say volatile, the compiler will not optimize that section, and that's fine, because you're dealing with critical information, and you don't want the compiler to mess the things up. So let's go to the code. Let's code a little bit right now. This is what I want to do with you guys. Let's go to our C++ compiler. But the C++, I'm saying C++ compiler, but actually the compiler supports too many languages, as you can see. And right now we're gonna use C. So this is a C code. We don't need these are too many supported language, but we don't care. So here we have an hello world. This is the first program. Let's run it. And this is hello world. The program is running. So let's move on. Let's declare a variable. How do you declare a variable? You say int, an integer number, and you say number. Number is a variable, and you can say that this number is equal to 11, for example. And here you can say, for example, auto. If you say auto, you don't say, it doesn't matter, as I explained before. Let's take it out. So here, let's learn a little bit more about the printf function. Let's see. Here you have hello world. This is a string. This is a string. This is string is a way to we call text in programming. So let's take it out. But inside this we put this percent signal, and we can write and I means integer, a comma, and here you put the variable number. This is how printf works with types which are not string. If the type is string or text, you could leave as it was like this. But right now we're dealing with different types of variables. So you put here the type of the variable and here the variable. Then the variable will be printed here below. So let's see. Okay, that's fine. The variable was printed. Okay, this is an auto variable, local variable. Let's create two variables. Let's say a variable is x, and we have another variable which is, for example, y. And this y, let's put 2, and x, let's say x is 1, for example, maybe 1 or 10, and this is 20. No, this is 10 and this is 20. So let's put here the x, comma, the y. We cannot put two values here right now because we said to the printf function we will only use one integer number, so we have to add the other right here. We can put any character here, for example, comma, and we put a comma or even hyphen, but let's use semicolon, and let's put here the variable. This is another one which is an integer or a digit. That's the same as we learned on the last lesson. This is the same in I or D are both int. So let's move on. And we have 10. This is the semicolon which is in the middle. Okay, we can put a space here. Okay, that's fine in my opinion. Right now, let's check it out. We know how to use const. No, we don't know yet. Let's use const. But before using const, let me show you the difference between global and local variable. Let's put here some variable which is, for example, float t. T is a const that you know it is 3.1415, something like that. This is p is a const. And now, as this p is outside this block of information, this is, I'm saying p, but you can say pi. This is a local scope, and pi is global variable, so we can use it right here. Let's put here comma, let's put pi, and here we have to add some more value. Let's say this is a float. A float is an f. Now we can compile, and we have that. We have the three values. That's fine. That's fantastic. This is global. Let's create two different scopes in order for you to see. This is, let's create scopes using curly braces. You create scopes by using curly braces. This is inside this curly brace, these two curly braces. We have a scope, and inside that scope, we can put this, for example. Let's put this, and let's create another scope right here below, and let's put the other variable inside that scope. Um, as you can see, we have this, which is taking our space. Let's take it out, and this becomes void. Void is also a reserved name in C, which means nothing. Okay, so that's fine. Let's put this printf below as well, and here we have the x. This is x. Let's take it out. Let's take the y out, and here let's take the x out. So here we need a digit, a single digit, and here we need a single digit. So this is a digit, an integer. Let's call it integer, and this is a float. So x is integer and pi is float. Here, this is an integer and this is a float. Y is an integer and this is float. Okay, that's fine. Now let's compile. But before compiling, let's separate the output, this output from this. In order to separate this here at the end, we can put slash, inverted slash, and end. This that means to new line. That means new line. Okay, so let's move on. And as you can see here, we have the new line because we put the slash n. If we take the slash n out, we don't have the new line. This is a mess. Okay, so let's put the new line. That's perfect. As you can see, this is a global variable we can use inside this scope and also inside this scope. But this variable x, we cannot use here x because x is not known inside this scope, because x is only local to this scope. If I try, the compiler give us an error. It's saying x is not declared in this scope, but y is. Okay, this is the difference between a global and local variable. But now let's talk a little bit about the const. This variable, if I say const, this is not const. Let's say that's not const, and we have pi here. Right now, let's work with circle. If we want to work with circle, we need a radius. Okay, this is a radius, and besides the radius, we need the pi. Okay, and let's say this is the radius, and we put here the radius, and the pi. We declare here pi with this value, and right now, I want to change the value of pi. Let's change. Let's say now this is 12, for example, or it is 4, or only 3, for example, 3.0. As you can see, we have 3.0 right here without any kind of problem. That's, as you can see. But see, you can see that we have 3 dot too many zeros. You can format that using the printf function. Um, you can say something like uh, um, two floats, for example. Let me make it sure not to float. This is something like, no, I don't remember. Yeah, that's fine now. You say dot two and float, and you have only two decimals. So let's take it out. Let's take it out, or no problem. And now if I say const here, because of the word const, I cannot change the value anymore. Let's see. Okay, we have an error because this is a const now, and the programmer should not modify a const. The value is constant. What can we do right now? We can calculate something good, which is the, let's say, float the diameter of the circle. This is the radius, diameter, radius, and we can say the diameter is radius times radius. Okay, and here we can put the diameter, which is the radius of a circle is 10. So the is the diameter radius versus radius? No, that's not true. It is 2 times radius. Yeah, this is 2 times radius because the which number is that? This is bad. This is very bad. This is bad because this number is an integer, but we saying here, no, that's, let me check it out. We have a problem, but we can find out easily. That's fine. This is fine. Okay, this is the second one, which is fine. The first one is the one with the problem because we using d here. D is a float, not an integer. So This is a float now, okay? This is a float. Float, D is float, and P is also float. So that's fine now. We can also put here the dot one, for example, dot one, and we won't have any kind of problem right now. So that's fine in my opinion. And what can we do? Let's calculate the area of the circle. In order to calculate the area of the circle, we need this p, this constant, and we need the radius. So instead of calculating the diameter, let's calculate the area. Now let's calculate the area. That's the area. And for the area, we need the radius. This is something like radius multiplied by radius, which is a radius power 2. And then you multiply this by the constant, okay? This is the area of the circle. This value here is the area. That's fantastic. That's fantastic. But what can we do right now? We can. Yeah, that's fine for me. You know how to use const, and now we can use static. Static. I'm not going to explain right now static, but if I say static here, I don't have static int. Okay, static int. We don't have any kind of problem. But in the future, you learn more about static. What can we do more? We can also use extern and register and volatile. Let's use register. Let's see. We take the const here and we put register. A register cannot be global. This is an error, okay? But if you say volatile, we don't have any problem because that can be global. But this is const. Okay? Good practice. So now instead of static, let's put here register. This is fine because this radius is used only as soon as possible here, and we don't need it anymore. That's fine to be a register. Okay, that's a good definition for register, and that works fine. What about extern? Extern, let's say this is extern. This is extern. Let's check it out. We have an error because we saying that this is extern, but we here are modifying an external value. That doesn't make any sense. Okay. Let's try to say something extern int a, something like that. We shouldn't do that. We shouldn't do that because an extern must not be initialized because this is extern. This must only be a declaration, okay, not a definition of the variable. So as you can see, that's fine. But what if we now say a is 10, something like that? Okay. That's bad. That doesn't work because that variable must be defined somewhere else. I think that's fine. We covered every scenario for today, and the time is fine, 30 minutes. Thanks a lot for those who watched my video. I hope you subscribe my channel, Tekniikka High Tech. We'll be bringing to you cutting edge technology, very bleeding edge, and you like a lot. We in the near future we're gonna talk about cryptocurrencies, artificial intelligence. These are the two areas that I like the most. But right now, I'm giving you the basis of programming. The C program is the most fundamental language nowadays. Okay, thanks a lot. Subscribe and leave some comments to me for in order to improve my course. Thanks a lot, guys.